So hello everyone, welcome back to my channel. Hope you are doing good. Today we are at day 22 of the April Daily Leetcode Challenge, and we have a hard level question in front of us. It's question 1312. Minimum insertion steps to make a string palindrome. I hope you are aware of the definition of palindrome. See, I will just quickly give example of what a palindrome is. Palindrome means, for example, this. Okay, whichever string reads the same from, for example, see, if we read from the left to right, it becomes NITIN. Okay, if we read now from right to left, okay, it's the same NITIN. Okay, so this kind of things are called palindrome. Okay, these kind of things are called palindrome because see, they have given the definition as well. It's the word that reads backward as well as same as well as forward. Okay, that means if we read from the left to right or from right to left, it is exactly the same. Okay, that is the definition of palindrome. Now, in this question, the ask is we are given a string S. In one step, we can insert any character at any index of the string. Okay. In one step, we can insert any character at any index of the string. Return the minimum number of steps to make the S palindrome. Okay. Let us see some examples quickly, and then will be easy to understand for us. Okay. So this time I'm going to code in front of you so that you understand how it's done, right? It's very see, you are seeing it as a hard question, but actually it's not a hard question. It is a harder in the sense, yeah, overall solution is harder, but if you know how to code this a problem, then it becomes very easy. I will show you how. It will take nearly 5 to 7 seconds for me to code the solution. I will show you how. Okay. For example, let's quickly see. Let us spend some more time on the examples. Okay. It will be very easy for you to understand after that. Okay. See the first example. See, what the ask of the question is, we have to return the minimum number of steps to make as palindrome. Palindrome means it's read the same in the way if we read from right to left or left to right. It's the same. Okay. In this particular example, see Z is here, Z is here. Okay. Similarly, Z is here, Z is here. Okay. A is in middle, so we don't need to compensate for A. So it's already a palindrome. It's already a palindrome. So we do not need to make any insertions. So they're asking million number of steps to make as palindrome. We don't need to see step is defined here. Step means you can insert any character and index of the string. We don't need to make any number of steps. Okay, we don't need anything. That's why what we are doing is the answer is 0. Now come to the second example. Okay, second example, I have traced it here. Okay, I have traced it here. So this is the second example. See, I will calculate the minimum number of insertions. I will write it here. Okay, whatever I am inserting, I will write it here. And this is the example. Okay, now let us do step by step. Okay, this M is compensated by this M. Okay, we are done. Coming to this index B. There's nothing to compensate for B here. Okay, I have to insert a B here. I will write B here. Okay, so the number of insertions is 1. So this B I compensated with this B. Now coming to this, see D is here. Okay, I need to compensate for D. So there's no D here, right? I have to include a D. Okay. So minimum combination become 2. Okay. And then finally we are at A. A is common in both the, see, if we read from left to right or from right to left, A is at the center. So the center one need not be compensated. Okay. So we don't need to do anything for A. Okay. Now if we read from left to right, okay, left to right it's like this. Left to right. Or if we read from right to left, it's the same. Okay. So what are the minimum insertion we did? We did 2 insertions. Okay. That's what is given here. We require 2 insertions, and finally hashtag can be one of these. Okay, it has to be a polynomial. That is the only demand of the question. It can be in any way. Okay, it can be in any way. Now coming to the third example, it's slightly lengthy and harder, but please try to understand this example as well. Okay, see, please monitor here. See, it's difficult to explain if you are missing it out, but in the best part of YouTube is you can pause the video and you can remind anytime. Okay, please do that if you have any doubts. See, L. Okay, we need to compensate for L first of all. Okay, so I would put a L here. Okay, and the minimum insertion is 1. Okay. Then I need to compensate for E. Okay, E is already there. Okay, E is already there. I will not do anything. Okay, there's another E now. I need to compensate for another E. Okay, I will insert that E here. Okay, I inserted E here. Minimum insertion became 2. Okay, then a T came. Okay, I need to compensate for a T. So we will include a T here. Okay, minimum insertion became 3. Okay, then a C came. I need to compensate for a C now. So I will insert a C here. So it became 4. C came, now came O. Okay, there is no O here, so we need to compensate for O as well. O, so it became 5. Okay, you can see these are the only character now. Okay, so these in the middle. You see this part. If you read from right to left is exactly the same as this part. Okay, Leetcode. Okay, so this is a palindrome now. Just check it once. It is a palindrome now. Try to read it from left to right. Okay, Leetcode. Okay, and now try to read it from right to left. Leetcode. Okay, and then the other thing continues. So that is what they are saying. So we required 5 insertions for this. Okay, that is what is given here. Okay, and they are also getting the same string COD and the same part of it again. Okay, so D in the middle, that is the only thing which you need to consider. Okay, so this was how we are doing in the example. Now let us find a solution for this. Okay, so as I told, I will be showing this how you can code this within 5 seconds if you have solved the upper little code challenge. Okay, let us understand what is happening here. Okay, so this is my first example. Okay, MBADM. Okay, the length is 5. You can just count it for yourself. It's 5. Now tell me what is the longest palindromic subsequence. Longest palindromic subsequence means you will have to go to day 14. Okay, I will just show you quickly. Okay, please go to day 14 of the April Little Road Challenge and try to understand this question. Okay, longest palindromic subsequence. Okay, here they've given some examples. For example, for this string, longest palindromic subsequence is BBB. Okay, so whichever subsequence, which see they've given the definition of subsequence as well. I'm not going in depth of it because I'm expecting you to see that video and get the idea by that. Okay, I'm not going in depth of it because this video will become very long. But just try to understand what is the longest palindromic subsequence, and we are trying to use it here. Okay, so coming to this. For this example, what is the longest palindromic subsequence? LPS means longest palindromic subsequence. It is MAM. Okay, it is MAM. What is the length of the longest palindromic subsequence? It is 3. So my original string has length 5. My longest palindromic subsequence has a length 3. But we know the minimum instructions. The answer for this question is n equal means 2. Okay, so how you can relate 5, 3, and 2. Okay, so that's what we are trying to find. Minimum number of steps to make the string palindrome. How we can relate this to? See, LPS is a length 3. Okay, the given string is of length 5. How we can relate the two? What I can see is 5 minus 3 equals to 2 is the answer. Okay, 5, I will just reduce the font. 5 minus 3 equal to 2 is the answer. You can see I2 is the answer, right? Let us see if this logic works somewhere else. Okay, in the other example, n is 8. Okay, what is the LPS here, longest palindromic subsequence here? You can clearly see triple E. Okay, this two E's. Okay, these two E's and this another E is also. So this forms the longest palindromic subsequence here. Okay, so what is the length of the LPS? It is 3. So what we can do, we can let us check if this thing works in this example as well. 8 minus 3, which is 5. You can see 5 is already the answer of this we calculated just now. So this thing works. So what how to solve this problem is we will find the longest palindromic subsequence, we will find the length of the longest palindromic subsequence, we will subtract the length with the length of the given string, and then we will get the answer. That is the basic idea of this question. Okay, how to find the LPS now? As I told already, I will be referring to the day 14th. Okay, we will be referring to day 14th question. Here we are solving this question with this particular function. It's I've already told you it's a O of n square in time complexity and O of n in space complexity. Okay, we have given a in detail overview of this in the day 14th solution. I will give you the link for that. Okay, in the comment section. Please go to that video, and if you're not aware of this, please see that. Okay, I will just copy this code and I will just show you how it works. Okay, I've just copied that code. Okay, I'm just pasting it here. Okay, so this is my code. Okay, this is a code which I have copied and pasted. Okay, this code will give me the longest polynomial subsequence length. Okay, it will give me the length. Now see, the return type is an integer. That means it will give me the length. Okay, now how to get the answer for the current question? What I will do is I will return length of the given string, which is s in this case, minus. Okay, minus this. I will find the length of the longest polynomial subsequence. Okay, run and see if it works. You can see it's getting accepted. Okay, So friends, that was the so see its time complexity and space complexity is going to remain the same. Okay, it's going to be O of n square in time complexity because we are having two for loops here. See, I'm not going to in detail of it because in that video I've given you in detail overview. I've even traced and shown you how it works. Okay, I've given a detailed overview and even the tracing part. Okay, tracing part is very important here because see, it's a defined logic. Okay, it's not something which you will like get on your own. Okay, it's a defined logic here. It's a defined algorithm. Okay, it's a very famous defined algorithm to find the longest palindromic subsequence, or you can say longest common subsequence. So these things are a defined algorithm. Okay, I don't expect you to learn this on your own. Okay, it's not something which you can invent on your own. It's already invented. We are just going to use it. Okay, so you will have to memorize this solution if you want to code this kind of solutions. Okay, this is something which you have to remember. See, coding is not always about finding logic. It's sometimes about reusing something which is already used. Okay, it's a very nice way of finding the longest common subsequence. That code we are using to find the longest palindrome subsequence, and in that code we are going to use to find this minimum insertion step to make a string palindrome. And time complexity, as I already told you, it's going to O of n square. Space complexity is O of n. Okay, so that was all, friends, for today. Sorry, space complexity is also going to O of n square because we are using a grid data structure here. Okay, we're using a 2D grid here. So that was our friends for today. If you have any doubts, please do comment below because see, as you might have thought, this question is going to be harder when they will using some DP solution, something. So actually, this is also a DP solution only, but this solution is a predefined one. Okay, we are coding it based on the predefined solution. Okay, this is a very famous algorithm of longest common subsequence. If you code it in the Wikipedia, you will get the algorithm as well. It's a famous algorithm. We are just reusing it. Okay, we are not coding it from scratch. So yeah, friends, that was all for today. If you have any doubts, please do comment below, and thanks a lot.